So I just wanted to get video of this really quick. Kind of what we're dealing with. So this is dark right now. Yeah. So if I bring up the color just a touch and start to talk about kind of what we're dealing with. Now, the idea here is I have a fractal, right? Well, I've started with a block of pretty much uniform density, right? And we're getting some artifacts with that, but that's something else. Anyway, the that comes from the step size, and that's been causing problems for a long time. You see the back face projected onto the front face sometimes. It's not ideal, but the notion here today is twofold. I have this fractal, right? So that's all this information that I have with the sign distance field, right? That's all contained in a very simple functional representation. And then that also allows me to get normals. Well, so this looks like it's higher resolution, mostly because it's way super sampled. So basically what that looks like is blue noise jittered samples, 32 of them per voxel when doing that selection logic. Here, I'll go to... This is the user shader editor, and this is very, very cool. So this is the distance estimator with its helper functions, and basically got some very simple logic to get normals, and that's using a specified epsilon value. These are just a couple different ones I found. Yeah, anyway, they there's a couple different methods for normals. Anyway, the ambient occlusion is also from Inigo Aquila's. Yeah, and he has this kind of logic of like, give me the normal, and then take a few steps along that normal, right? Normal. Yeah, you're right. So yeah, stepping along, right? Yeah, right. From position along the normal, checking the distance estimator against that. So that's basically looking at, like, off the surface, what does the ambient occlusion look like. Now, I don't have that actually applied right now. So basically what this has done is taken a uniform volume, and I'm just masking, right? I'm not even setting, I'm setting draw to false, which means that there's no manipulation of the color data. I'm simply setting the mask channel, and that's going to affect subsequent operations, like when I come in here and clear out the whole rest of the volume. So if I were to yeah, let's just go through the whole process again. So unmasking all voxels. Well, I'm just going to leave that. And then we're clearing it, right? So no masked voxels means none remain. XOR, we're going to go ahead and draw ourselves this. And the reason it has an orange cast is just because I've cleared the lighting buffer with a slightly orange value. Anyway, you can see the pronounced perspective projection. Now, a couple different directions you can go here, and what I'm gonna do is basically what I did last time. These are just very broad Gaussian blurs, just a whole bunch of them. And that makes it chug for a second, but you deal. And then you go back to the user shader, run this to set your masking. Right, and then we're gonna go back in here to clear, respect the mask, and then we're back to where I started the video essentially. Color is slightly different, but this is the remaining contents, right? And so we can go ahead and do lighting on this. And this is actually kind of cool because these darker spots actually have lower alpha, and they're gonna be, this is gonna be interesting maybe. Right, and so this is my ambient occlusion calculation that comes from the neighborhood occupancy. Let's go ahead and do a slight blur, only radius 1, and then come at this with directional lighting. So, right, so theta is rotation about the y-axis, right? And then phi is up and down. This declination kind of an idea, right? Elevation. So negative is above and positive is below. Anyway, this is kind of like medium to straight above. So if we're looking at this with the y-axis pointing up, and those weird banding patterns are from the XOR diffusing, so that's normal. Anyway, so yeah, you hit it with the light, and then yeah, so then you can kind of rotate about the y-axis if you wanted to. Maybe you want more blue, less red. You get that. And you can kind of, you know, figure out this fake global illumination is kind of like going down from the highest y value to the lowest y value. And at each step it's going and for every voxel in that vertical slice, it's looking at 9 arrows going, or 9 rays going upwards to the 9 voxels that would be, you know, sharing edges up above it. And you're stepping along that, looking for occupied voxels. If you don't hit any, you use a sky color. If you do hit some, you take light from that times the albedo that's there. So it's like kind of a scattering type of idea. It's not very good, but it works all right. It's kind of an interesting little hack that I found in the voxel automata terrain repository. I talked to the fellow who made that, Brent Wernes. He explained it to me. But yeah, I'm currently thinking about stochastic lighting operation right now. It's like a photon mapping kind of idea. And what that would kind of be is like just dumping in a whole bunch of particles that would bounce around inside the volume. And I'm thinking now on hit, you would then kind of like treat the voxel that you hit as a sphere and just bounce off the normal. And I think that the randomness would make that shake out to just be, you know, like a diffuse material. Right, because if you make that sphere the same radius as the center to corner distance of the voxel, then it's going to contain the entire voxel, and any ray that hits the voxel will hit the sphere. So I'm kind of thinking about looking into like supercover traversal, which is like the one that goes through and hits every single voxel on the ray. I haven't done that yet. Anyway, the directional lights, they, they're there. This is something that I think that there's a lot of room for improvement in, and I think that the user shader, when it has the signed distance field available to it, I think that there's a lot you can do there. I think that's worth investigating. So we're gonna hit this with some heavy purple and see what that kind of looks like. Because why not? Right, so you get like highlights and maybe even more. Right, and then I want to go maybe like 180 degrees around and do like green. And we'll go a little stronger on that. And so then we've got this kind of super weird color scheme on this thing, and then I can run this and see if we get maybe a little bit of bleed. It's not very pronounced, and it's only up along the y-axis the way that it runs. So it's maybe not the best approximation. Anyway, that's something that there's a lot of room for improvement there. You can apply any of these operations from the menu as many times as you want. So that's kind of the structure of the interaction here, is that it's very observe and interact kind of a thing. Yeah, and so I have like Vim style HJKL controls, and they all have a shift variant that moves more. Yeah, so that's really weird, the way that pattern formed there on the bottom. Like, it might be interesting to hit that from below with blue light. We'll go ahead and do like that. And then adjust it so it's coming from below. 1.4 is pi over 2, so that'll be from straight below. When we turn down the decay, that means that voxels become more transparent, right? That raises the alpha power, the power that the alpha sample is being raised to, and so when that's higher, it diffuses more easily into the material. Opaque materials, above like a certain amount are gonna stay, certainly sort of opaque, but yeah, you'll see some variation there. And if I'm able to, or if you watch and turn that down, that's just at the surface. Let's see if I can. We'll do it from above so that gives a little bit more context. Right, and you'll find that these lower decay values bring out harder edges because they decay faster. You get this hard shadow. Anyway, so the what you get there is like some interesting lighting scenarios. Oh, overshot slightly, but yeah, like you can kind of see how the lighting is coming in from different directions here, and you've got a little bit of interest going on here. And what is also cool is its floating point on the lighting buffer, so I do have some freedom to screw around and make problems. As far as the values have quite a range, I can generally do a lot with that. Okay, and so a radius of 0 means that it's being set by its own alpha value. Alright, and so some of these have thresholds that bring out sharper edges more than others. Others can make things look softer. Now, if I'm to move to another rotation and we're going to skew more heavily like orange here, now the orange light's coming from over here, and you can kind of see how the shadows are different. As you can kind of get a sense of where that's coming from, it's just kind of from the opposite direction. This thing makes some pretty cool pictures. I don't know, it's like the lighting buffer and the color buffer interacting is really cool, especially when you end up with pretty neutral colors like grayscale in the color buffer, like what I have done here with the XOR. It's got variation, obviously, due to the diffused out XOR values there, but you know, largely neutral. It doesn't have like a heavy skew towards blue or red or green, whatever. It's got activity in all channels. So when I come in here with these different colored lights, I don't have a bias towards any given light color. I have, you know, I can get this relatively uniform response from all the different lights. Whereas if you change the albedo, that's actually, there is almost kind of a physical metaphor going on there. You've got you know, it's only going to reflect the light that, you know, the surface is able to reflect, and so whatever that means for that surface, that's going to only be able to display values out which where you have albedo that you can scale up. And so you can kind of see some interesting thresholds that formed inside of there. Different lighting kind of brings those out. That has to do with the curve. As you raise that alpha value to a power, it's, you know, it hits certain things kind of like a brick wall, and then like you know, you get different scaling, and you get maybe a smoother curve. But yeah, those kind of sharper thresholds were that kind of a thing. Yeah, if you look at depth, that's maybe an interesting thing. This is, I guess, relatively subtle, especially when you have soft edges like you do here. There's a slow fall off from solid to negative space, and you can kind of see that in profile here, which means that you're, you know, these aren't maybe the best depth values to be using because they're alpha weighted, so it's rendered the same way as the regular renderer does, except it's now using, instead of color samples, it's using depth sample at the location. So it's kind of like an X-ray, kind of, I don't know. It's you know, for this type of visualizer, it's all right, but it doesn't. I haven't been able to use it for much else. There's also the position done the same way. Again, sampling. Right. Instead of sampling the albedo texture, we're sampling now position in 3-space XYZ to RGB inside of the volume. And then this isn't implemented yet, the super cover traversal, but there is a distinction between mapped linear traversal and a nearest sampling traversal. There is, if you look at the nearest sampling, we can start to see these real, you know, sharp distinctions here. But when I incorporate the bitmap and linear sampling, it really starts to make a lot more sense. Right, because you can see these large artifacts here. Go to linear sampling, much less pronounced. And as it starts to converge a bit, yeah, right. So this takes about 15 frames to converge. It's about a half second at 60 frames, well, 30, whatever, anyway. So it's like sub-second, usually. You know, it's got a lot going on, so it's kind of difficult to maybe keep that in check sometimes. But, you know, say you wanted to do, all right, here's something you can do. So if you set the sky color to 0, and then you apply this is basically only getting color from the surroundings, right? And then that maybe makes a bit more sense to use certain contexts, I don't know. And then I don't know what else, maybe kind of turn 90 degrees and do kind of something, yeah, just like that. And yeah. Yeah, it gets a little bit laggy sometimes, but we deal. And yeah, so especially with the global illumination function, that has an alpha threshold that it specifies, and so that creates an ISO surface by itself. Effectively, it's highlighting an ISO surface that has that alpha, and so that maybe creates some undesired artifacts. Now that's something that I hope to figure out with my my photon mapping ideas. Right, it's stochastic lighting, right? So we're looking at something where the traversal hits an occupied voxel. Okay, we're going to check a hash to see if, you know, right, we're going to look at higher chance to scatter with higher alpha value. So whatever it is, 1 minus the alpha checked against the hash, the float from the hash. You know, it's something along that line as far as structure. And the way that you can think about that is like, right, so it's some chance to bounce, and then when it does bounce, we're going to be scaling the amount of energy that's associated with that photon. And I'm not sure exactly what like the deposition logic is going to look like, how it deposits energy, but I have the lighting buffer and all that kind of stuff, so I'm hoping that basically just dumping them in from all sides kind of creates some kind of a global effect there. Or maybe just from kind of some sort of source above, or I don't know. Kind of have to think about that a little bit more. But so this is the inverse of what I've been doing with the path tracing. Is path tracing is very much going from eye to light source, the way that I've been doing it, and this here is now very much forward from the light source. So I think it's going to be an interesting approach. I really think with some of these things, like, you got in there with a copy paste function, you like cut out a little chunk of this stuff. Like, some of these generators that I put together, the fractal evaluator thing, like the user shader, being able to use that for arbitrary shit, and then like, okay, yeah, let's do this. I'm just gonna go ahead and mask everything that has an alpha channel that is above, right? So we're coming from above, right? So within almost full spread of 255, which means it's coming from 255 almost all the way down to 0. And I masked that at 255, which is masked fully, which basically means no overwriting. Now I come in here with my spaceship generator and I tell it, okay, I want a random palette. Just pick something. And I want 5 operations. I want small spread. Minimum scale of 1. And I don't want bigger than 2. And then I want this one higher. I want this like 25. And then we're gonna do that, and we're gonna do that. Okay, cool. And so what the spaceship generator is like all my font glyphs. They're just like in this database basically. That's like I don't have a good way to offset this from the center, unfortunately. Okay. But so you see how there's like arrows in there and stuff? That's basically what we're looking at. Lighting, I'm gonna put some ambient occlusion on that. Yeah, and that's the other thing, right? So once we start dealing with these different types of colors, it takes some fine tuning to kind of figure out what you want it to look like. Right, and then yeah, because I reset that to that, we'll go ahead and go for like a kind of like a medium green sky color. All right, and then you can kind of see where that's bringing out the ISO surface on the backside. And that's kind of weird, but that's like just that thresholding that's happening. Right, anyway, so you do get something like a global illumination effect, but I want to do that more. I think I've got a line on how to make that happen. The palette colors don't directly map to the colors that you see, which makes this a little bit difficult sometimes. It's using the palette, the demo scene style palette that Indigo Quill has put out. It's sick. Yeah, the demo scene palette that Indigo Quill has put out. This is nice. And so we're going to run that same masking operation to add masking on all of this new spaceship material. So then now I want to come in here with ambient occlusion. And we'll see what we can do with that. Okay. No, that's still above, and I want sort of more of a skew towards yellow. Yeah, and it's gonna go a little bit deeper. Turn down the intensity. Because, yeah, if you, right, and you can kind of see that was a little bit too much still. It gets a little bit washed out, right? It's the issue of too much energy being applied, basically. Right, but there's different ways to kind of rescale it back down, and maybe that doesn't look great, but something to start with. And I'm gonna go like kind of like a like a like a right. And so that kind of value, like 1.9, the light goes like pretty much all the way through it. And so yeah, you can kind of, I don't know, you get these grazing effects sometimes. I think that's very cool. Almost like a Fresnel kind of a thing, but it's a consequence of like traveling through more transparent samples. Yeah, and it becomes even more pronounced when you blur these objects. Right, and because those are masked, the original contents stay intact, and then they diffuse outwards from that original position. And so now if I clear the lighting, you can kind of see that now they have maybe a little bit of a halo around them. And then if I were to come in here with that light just by itself, it's gonna stop faster. But yeah, we can get that. And you can get all the shadowing and stuff. So now, we're gonna run that masking operation one more time, and then we're gonna do something to fill the space. So just a sphere of maximum radius with whatever contents that I'm looking for. Something, yeah, medium yellow area around what I want. Well, again, it's look at the skew, right? 183, 117, 38, right? So 38 needs to come way up. We need to kind of have something a little bit more balanced. Kind of, you know, these it's not any real hard and fast rule. It's just kind of getting a sense of where these ranges want to be. Right, and so when I reset these values, yeah, so that may be a little bit too opaque. And I have a similar adjustment to that decay factor. Actually, I may do it that way. I think that's probably the best way. That allows me to do similar adjustments and give myself more usable range in the alpha channel by raising it to a higher power. And so then lighting, you know, we'll try this again. It's going to need to be pretty strong to get through that amount of surrounding material. That is the problem with that. And then when you turn it down far enough, it's not strong enough by the time it hits the surface. So you get maybe not the best performance with the in terms of results with the lighting buffer the way that I'm doing it there. But Yeah, so you can make a real mess with this real fast, and it's kind of it's got a lot of room for creative potential, I think. Yeah.